Good day everyone, my name is Jesus Talingting and today we'll be presenting our automated toll booth system made using Java language. This Java application simulates a real-world toll collection system that processes four types of vehicles, which is motorcycles, cars, buses, and trucks, each with different toll rates. The system allows batch processing of multiple vehicles at once, validates user input to prevent errors, and maintains running totals. After each batch, it provides the option to process more vehicles or view a final summary report. At the end of the program, displays a comprehensive breakdown showing the count and the total revenue for each vehicle type, along with the overall collection. Let us demonstrate how it works.
Dongle greetings everyone, my name is Federico A. Celis. I'm here to present you a problem understanding and analysis. Now, for our problem, we need to do a simple toll booth simulator that can record user input and also provide a accurate output. Now, for input, we need to ask the user how many times he would like to repeat a specific program, which is how many times he would like to enter a specific vehicle. Now, after he pick a vehicle, the program will prompt if he would like to repeat the program, which is it will prompt different vehicles. Now, for the process, it's the same. The user will ask would he would like to determine how many times the user chose to irritate it, and then their selected vehicles are recorded, assigned to the toll, and those vehicles have different prices. Now those prices are added to the sum, and after you get the sum, I mean it will print in the end of the output after you don't want to do repeat the program anymore. Now, uh, the user before it will end in the process, you need to ask the user how will he would like to if he would like to continue the program or no. If yes, it will still repeat to the same process, which is user input the specific car he wants, and then recorded it again, and then for if he said no, he the program will print it will print the total sum of how much collected, or the total sum of the vehicle toll booth simulator collected. Now, for this for our output, which is the no condition in our code, if no, it will print our total prices. I mean total vehicle sum. It will total the sum of all around vehicles, how many motors pass to the toll booth simulator. Just like example, you have 13 motors passed, and then 10 cars, just like that. And then after that, that's the output. It will prompt the total amount of sum collected to those vehicles. And that's it. Thank you. Thank you. Have a good day.
Greetings everyone, I am John Arman M. Gonzalvo. As you remember me, I was assigned in the part before in testing and debugging a program, but now here I am in front of you. I was assigned in algorithm. So this day, I will tackle in front of you in algorithm of our code. So step 1 is to start or to begin. Then step 2, import a Java util package scanner and create a scanner object. How do we do it? We simply put the import java.util.scanner. Let me show you. So as you can see here in the top, in number 1, we have import java.util.scanner, semicolon. We shouldn't forget to put semicolon on the end of the code so that we can avoid errors. So you must write import java.util.scanner to tell Java where to find the scanner class. So what is the step 3? The step 3 is to declare the variables and their values. Again, let me show you the code of it. This is the initialization of the variables. The integer is total motorcycles equals to 0, total cars is equals to 0, total buses equals to 0, total trucks equals to 0, double total collected equals 0.0. Character, continuous simulation, and vehicle type. So, local variables must be initialized before use to prevent compile time errors. Instance variables get default values, avoids undefined behavior. Proper initialization makes logic correct and code readable. So if you don't initialize it, that means we have already an error. So let's do not forget to initialize our variable before we proceed in the main code. Okay? Sorry to keep you waiting, but here is the step 4. Execute a do loop to display automated tollbooth into the console while prompting the user for the number of vehicles input. The purpose of do and the bracket is to start the loop by running the code at least once before checking the condition. Let me show you once again. Here is the do loop. Yes. Next we have step 5. Read user input. The program should read the user's input. Then step 6. Use a do loop to print the cost of toll gate for each type of vehicles. Once again, we should use the do loop. Here, like this. Already get it? I hope you're not confused. Let's go to step 7. Implement a for loop to check how many times the program would iterate the batch of vehicles. A for loop in Java is used to execute a block of code repeatedly as long as specified condition is true. So what does this mean? The program will run and run and run, meaning it is looping unless you input the true value. For example, you input -1, but the program do not want to read -1. So if you put -1, -1, -1, that means how many you put -1, the more the looping is continuing. Okay? But if you put positive, for example, the program needs a positive integer. So if you put a positive integer, you can continue to the next process. But if you put negative integer, that means you will get a looping. Okay? You understand? Step 8. Use a while loop to validate user input while prompting the user for another input. Let me show you what the while loop is. You see here, the while loop. So, what is the difference of for loop, while loop, and do while loop? I will give you some time to think about it. Okay? Start. Okay, so let's go back. Are you done thinking? Okay, the purpose of for loop. For loop is used when you know exactly how many times you want to repeat a block of code. So the second one is while loop. The purpose of while loop is used when you don't know how many times you need to loop. The code repeats as long as the condition is true. As I told you before, the code or the program will run and run and run if you don't input the right input. Okay? So, the last one is the do while loop. What is the purpose of do while loop? Similar to while, but guarantees at least one execution even if the condition is false. I guess you got it right. Wait. Hold on. Before we proceed to the last part, let's go and tackle the differentiation of for loop, while loop, and do while loop. So let's begin. I have the one and only PowerPoint presentation for you to understand my discussion. Yeah, sorry to keep you waiting, but here is the differentiation of for loop, while loop, do while loop. So here's the syntax of for loop. For the syntax of for loop, we have to put for, then column, initialization, semicolon, condition, semicolon, update, closing parenthesis, then bracket. Then after that, we put the code, then closing bracket. Okay? Next is the syntax of while loop. First, the changes, well, as you can see here, the initialization is at the top. Then semicolon, while, then parenthesis, condition, then parenthesis once again, opening bracket, then code. Then update, semicolon, then closing bracket. Lastly, do while loop. First things first, we put initialization, semicolon, do opening bracket, code, update, semicolon, closing bracket, while, open parenthesis, condition, then closing parenthesis, semicolon. So, we have to tackle what is the purpose of initialization, condition, and update. The purpose of initialization sets up the starting point of the loop. When it runs, it only runs once before the loop begins. Then condition. The purpose of condition tests whether the loop should continue running. When it runs, before every iteration of the loop. If it's false, the loop stops. Then lastly, the update. The purpose of the update is to change the loop variable or another value after each iteration when it runs at the end of every loop iteration. For example, the initialization always starts with 1 because it is the starting point, obviously. Then we have the condition. The condition tells whether how many times we need to make a loop. For example, we put 10. So starting from initialization, the number 1, then stops until it reaches 10. Then the update. The update means to add, and add, or minus, minus, minus. Okay? So, for example, you put, I will give example, a variable named counter. If you put counter plus plus, that means the variable will add and add and add and add. If you put counter minus minus, the mm, the number will go back. For example, from 1 become to 0, negative 1, negative 2, negative 3, negative 4, negative 5, until negative 10. Always look on condition. Because if you don't look at your condition, you will get an infinite loop. For example, you put 10 in the condition, but in the update, you put minus minus, counter minus minus. So what will happen? So, the result of it will get an infinite loop. As I mentioned earlier, the number will go from 1 to negative 1 and so forth. Non-stop, okay? So, we need to think twice or more. We need to think twice or more on our code so that we will avoid the infinite loop. Okay? So, if the infinite loop occurs, that means you get already an error. Understood? So, let's proceed to the last part. Now, let's proceed to step 9. Step 9 is read user input. Once again, this is John Arman M. Gonzalvo, and greetings everyone if you listen to me, but the next step will be continued by the next reporter.
My name is Aaron James Camu. I would discuss the last part of algorithm. So after the program with the user input, the next step is to implement a switch statement to determine the type of vehicles and their equivalent toll fee using the given user input. On step 11, if the user input didn't match any of the conditions, the program would execute default keyword, displaying invalid choice try again into the console, while prompting the user for another input. On step 12, after all the iterations are met, the program would execute a do loop, prompting the user for another round of simulation. On step 13, use if statement to check if the user input matches the condition. Otherwise, print invalid choice into the console. On step 14, use a while loop to recheck if the user input matches the conditions. On step 15, implement another while loop to verify if there's going to be another iteration. Otherwise, on step 16, if the user input is equivalent to the symbol of n, the program would print the tollbooth summary and its receipt into the console. Step 17. This is the part where we would close the scanner. And finally, step 18. This is the end of the program.
Greetings. My name is Patrick James Anito, and today I'll be explaining the pseudocode of our automated toolboot system step by step. Let's begin. The pseudocode starts with the word start, which marks the beginning of the process. After that, it declares several variables. It says total motorcycle, total cars, total bus, total trucks, all to 0. This will record how many of each type of vehicle passes through the toll gate. Next, the program declares total collected and set it to 0.0, which stores the total money collected. It also declares continuous simulation, which will help control whether the program continues or stops later. Once all the variables are ready, the program enters a repeat loop, allowing the user to process multiple batches of vehicles. Inside the loop, this one, it displays the heading of automated toolbox, this one, and has how many vehicles. And the user input in this enters in this vehicle count. Then the program shows the menu of vehicle types and toll rates, this one. After showing the menu, the program starts a for loop that runs from 1 up to the number of vehicles entered. This means the loop repeats once for every vehicle in that batch. Inside this loop, a variable called vehicle type is declared, and valid input is true, set to true to make sure the user enters a correct choice. Next, the program enters a while loop that keeps asking for input until a valid choice is given. The prompt says, vehicle X, enter your choice 1 to 4, where X is the current vehicle number. If the user enters 1, it means motorcycle. The program adds 1 to total motorcycle and 50 pesos to total collected, then displays total 50 pesos. This one. If user enters 2, it means car. The program adds it to total cars and 100 pesos to total collected, then displays total of 100 pesos. If the user entered 3, it means bus. The program add 1 to total buses and 150 pesos to total collected, then displays total 150 pesos. If the user enters 4, it means truck. The program adds 1 to total truck and 200 pesos to total collect, then displays total of 200 pesos. If the input is not between 1 and 4, the program prints invalid choice and repeats the while loop until the input is correct. Once the input is correct, valid input becomes false and the program moves to the next vehicle in the for loop.
Dangal greetings once again. My name is Jasper Manimtim, and now I'll continue explaining the second part of the pseudocode. After all vehicles in the batch are processed, the program asks the user if they want to process another batch. It shows the message process another batch, Y and N, and stores the answer in continuous simulation. To make sure the answer is valid, the program uses another repeat loop. If the user types anything other than Y and N, it displays invalid choice and asks again. If the user types Y, which means yes, process another batch, the program returns to the top of the repeat loop and start over again. If the user types N, which means no, stop the simulation, the repeat loop ends and the program moves to the summary part. The program displays a toolboot summary. It shows the total number of each vehicle type and how much money each group collected. Motorcycles multiplied by 50 pesos, cars multiplied by 100 pesos, buses multiplied by 150 pesos, trucks multiplied by 200 pesos. After that, it prints the overall total collected, which is the total money from all vehicles and all batches. Finally, the program display thank you, close scanner, and ends with the word end.
Dangal greetings everyone. I'm Frederick O. Gecalao and we're about to tackle Flowchart. It starts by initializing totals for motorcycles, cars, buses, trucks, and the total money collected to 0. The program then asks how many vehicles are in the current batch and displays a menu with 4 vehicle types and their tolls. Motorcycle is 50, car is 100, bus is 150, truck is 200 for each vehicle in the batch. Prompt the user to enter type 1 to 4. Validate input. If it's invalid, display invalid choice. Try again. And reprompt for valid choice. Increment the appropriate vehicle counter and add the corresponding toll to the total collected. After processing the batch, ask whether to ask another batch, yes or no. If yes, repeat the requesting a new vehicle count. If no, display a summary showing count for each vehicle type and total toll collected. and it's the end of the program.
Dangal greetings, my name is Rayleigh Lorenzo A. Librada, and I'll be explaining the code that we use in our project. So the first step is importing the scanner, then we declare variables that we're gonna use later on. Okay. The first, we ask the users how many vehicle is gonna pass through our toll booth. Let's put 3 here. Then it's gonna display the vehicle types along with the price, and it's gonna ask to pick a number 1 to 4 so it could determine which vehicle is gonna pass through and its price. It's gonna be determined by using this switch case right here. The motorcycle plus plus will determine the total amount of motorcycles that pass through. Then the total amount collected is universal, so if they choose 4, it's gonna add 200. If it's choose 3, it's gonna add 150 to the final summary. Okay, let's try with 1, 2, 3. Then it's gonna ask if the user wants to process another batch of vehicles. If we put Y, it's gonna ask how many vehicles. You can put like 4. Then it's just a repeat, so it's just type here. Now it's gonna ask another one, so we're gonna just end and check the summary. As you can see in the summary, we can see the total amount of motorcycles, cars, buses, and trucks that passes through along with their price in total. And the total collected, if we add all of this, is 800, as you can see. Now let's try another one. Let's try 5. Then we'll check the input error. As you can see, if you click more than 4, it's gonna be a valid choice and we'll ask you to try again. Okay, let's continue now. Here naman, if we choose another digit or another letter, it's also gonna put invalid choice and ask you again. Okay. Let's see. And that is all. Thank you for listening.
Dangal greetings everyone. I'm Andre Nathaniel Galvez and welcome. Today I'm excited to walk you through the testing phase of our automated tool boot program. Our goal was twofold. First, to confirm that all the core functions work perfectly, and second, that to demonstrate a key enhancement we implemented to make the program exceptionally user-friendly and reliable. Let's go. Let's first look at the top of row of our testing sheet. This example shows the program basic logic in action. On the far left, you can see a simple single vehicle transaction. The user select car, the program applies to the correct 100 tool, and the summary is generated. It's clean, simple, and accurate. Next, we tested its ability to handle multiple vehicles in a single batch. In the middle example, we processed a motorcycle and a bus. The product handled both inputs sequentially and correctly calculated the total collected amount of 200. We then push it even further with 3 vehicles. And as you can see in the vehicle 4 test at the bottom left, we ran a transaction with all 4 vehicle types. The program flawlessly processed each one of calculated the correct grand total of 500. This test proved that the fundamental logic of our system selecting vehicles and calculating tools is 100% solid and working as intended. Now, here is where our program really stands out. A good program shouldn't just work when the user does everything right. It needs to be smart enough to handle user mistakes. This brings us to the most important feature on this slide, demonstrated in the 2 boxes labeled blue. Think about what usually happens if a user accidentally types a letter like capital A instead of a number. Or what if they enter a number that isn't valid choice, like 5 or -2? In many simple programs, this will be cause a confusing error or even crash the application. So we prevented this with a robust input validation loop. As you can see in the example, when the user enters an invalid choice or our program doesn't fail, instead it displays a very clear, helpful message like invalid choice or try again. Then it simply asks for the input again. The program will not proceed until a valid number, in this case like 1, 2, 3, or 4 is entered. This ensures that only clean, correct data is processed. It makes the system effectively crash-proof from bad input and guides the user to enter the correct information without frustration. This small detail make a huge difference in creating a professional and reliable user experience. So to summarize, our comprehensive testing confirms two key achievements. First, the core functionality of our automated tool boot is fully operational and accurate for both single and batch a transaction. And second, through the implementation of intelligent validation loop, we have created a robust and user-friendly program that is resilient to user error. This ensures a smooth and reliable experience for every user. That's it. Thank you for your time.
So, hi everyone, my name is Lozada, and I'm going to talk about debugging and fixing the errors of our program. So, let's first run this program and see if there's any error. Say one vehicle, and number two, which is car. So yeah, there's an error of this program. As you can see here, uh, it's the program adds more fees, although the program run and operate, but it incorrectly adds more toll fees. So we're going to find the error in the code. Let's just clear this. So the error here is in line number 46. Because the break is removed after the case 2, that's why it also ran the case after the case 2. So we're going to add break here after the case 2 break, and going to try to run this again. So how many vehicles? Say one vehicle, and say motorcycle. So yeah, after we add the brake, after the case 2, it just show the program just show the corresponding amount of the vehicle, which is just the motorcycle, unlike before. Like uh, before the program adds more toll fees even if you just input one vehicle, and that's why we need debugging, because it helps you locate exactly where the problem is and understand why it happens. Although uh, the program runs before, it's not accurate, and the user might probably uh, have a problem using this program. So yeah.